Hello, guys. Welcome to another episode of Cuda Education. Today, we want to focus on all things pipeline. So, we have to now dive into the render pipeline for this application. We are in the Hello Triangle app, and we are talking render pipeline, right? So, the render pipeline basically pipeline is a compiled object that sits between shaders and rendering. So shaders are code that lives on the GPU, and executes instructions, but it lives on the GPU. And rendering, of course, is just like drawing frames, things of that nature, and of course, yeah, drawing frames, so we actually see a triangle rotating, and it's eventually presented to the screen. Okay, so we have our Hello Triangle app, as we have done many times, and we are going to focus on the we're going to focus on the pipeline for today. So let's kick things off, and have a little patience with me, guys, because we do have quite a bit of stuff to cover. Okay, so let's kick things off. So here, we sort of, I guess you would call it, initialize a variable. A render pipeline the app creates at runtime. The app creates the pipeline with vertex and fragment shaders in shaders.metal source code. So this is the shader code that I'm talking about. This is not creating a pipeline. This is just, sort of initializing a variable, and doing the groundwork for everything else to happen. So nothing real has happened here yet. We have ID, MTL render pipeline state as our main variable that will drive everything. This shaders.metal, so shaders again is what is code that lives on the GPU and all of that good stuff. In our shader code, we have a vertex shader, and we have a fragment shader, right? And all of this instructions and stuff is gonna be baked into our pipeline at some point. But let us just get back to where we were. So we initialize a render pipeline state variable of type MTL render pipeline state. Okay, we have to be very careful about what's actually done, and we'll get into that in a second. This variable is written once during initialization, and it's read every frame during rendering. Okay, so we have a first. It's sort of the labeling is a little confusing, but this says compiler render pipeline state for the view, but no compilation really happens here. Okay, so render pipeline state equals self compile render pipeline view dot color pixel format, right? So we investigated compilation with we investigated this function before, compile render pipeline, right? View.color pixel format, right? And this is all associated with our variable render pipeline state. Now, this compile render pipeline is a method that we wrote and we discussed in the previous episode. It's defined in Metal for renderer plus compilation, and it's part of your renderer's implementation. It does not create a pipeline itself, right? So here is not where the pipeline is actually created. It does not. It basically creates a pipeline, builds a pipeline descriptor, optionally configures archives. So archives is sort of like, if you want to save this compilation for later use, you could do that just to save the step. calls the metal API to do the real work and returns the result. Okay. So it does not, yeah, it's not actually compiling the render pipeline for our purposes quite yet. I do want to dive into this because you know, it creates a configuration for the render pipeline the method compiles, right? So this variable, this descriptor variable, is very important, and we're going to fill it with information. So you could already see right here that this descriptor variable is configure render pipeline, and it's being associated with I guess I would call the color attachment and all of that stuff. But you know, we went over this stuff in great detail. Notice that you know, we're choosing creates a compiler, builds a pipeline descriptor, right? Just the kind of the variable, right? And then it does attach something to it. Configures the archives, calls the metal API to do the real work, returns the result. Really quickly, I don't really want to jump ahead, but notice that in this compile render pipeline, here is where the actual real work of creating the pipeline is done, right? But let us hold our horses for a minute. We will get to this in a second. All right, so let us just repeat. So up here we sort of initialize the variable, and then we do sort of this we call this compile render pipeline function, right? But this, inside of this, is where the actual compilation happens for the render pipeline state, okay? But this, right, so this in and of itself is sort of the initialization step in terms of creating the descriptor variable, choosing a compiler, creating the descriptor variable, optionally configures the archives, and then calls the metal API to do the real work, and then returns the result, right? And you know, this is the result that's returned. It's the compiled render pipeline. Right? So the pipeline descriptor is created. So the pipeline descriptor is created. Configure render pipeline. So here is where we initialize this descriptor now, and then with the descriptor now, we are trying to give it more information. So we have this compile render pipeline, and in it we basically creates and configures the renderer's only render pipeline. So an output data format for the new render pipeline produces, right? So this is sort of the pixel format stuff. And then also inside of it, we do some other work. So we have the pixel format, we have the vertex shader configuration, and the fragment shader configuration. So all of this is being baked into the render pipeline descriptor. Okay, so the render pipeline descriptor uh, that's what is being baked into this variable, and that then goes into render pipeline state eventually. Okay, so it's sort of a string of commands that's broken up into different functions, but you know, we have to associate the pipeline with the vertex shader and the fragment shader, and that's what's sort of done here. Um, the pipeline descriptor is the pipeline descriptor is the recipe. It's not the executable. Okay, so we are we're just lining up all the planets for what's going to be inside of our pipeline, right? Notice that this is all happening before we actually create the compile and create the actual pipeline here, right? So the descriptor is just basically we're baking in all the information into the pipeline, and it is associated with all of this stuff down here. Okay, so let's just look at this color pixel format for a second. So if we go to color pixel format, which is in the metal for this color pixel format, it is the pipeline is compiled. It's basically the pipeline is being compiled specifically for this view, and the pipeline assumes all draws will target textures of this format. Okay, this cannot change later without recompiling the pipeline. Okay, so I know it's a little bit fragmented at this point, but I will quickly go over it again so we put everything together. Let us discuss now the make vertex shader configuration and make fragment shader configuration. That stuff, we are in the Metal 4 renderer plus compilation. That stuff lives down here, and basically what we're doing is we are associating the vertex shader and the fragment shader respectively to the pipeline. Creates a library function descriptor for the app's vertex shader. Xcode compiles the vertex shader GPU function, right? Remember, it's a shader stuff, so GPU function in the shaders.metal source code file into the app's default library. So we have this for the vertex shader, and we have this for the fragment shader. For the vertex shader, at pipeline compile time, Metal resolves vertex shader, validates its inputs and outputs, and records its interface. Okay, this default library stuff. Okay, let us just get into that for a second. Create a default library instance which contains the project's shaders. Okay, so this is where we associate all the shaders .metal. All the shaders. We basically bring it in. We bring it in so that we could access it. For the pipeline and then compile it, right? So we have the vertex shader and we have it for the fragment shader. Pretty much the same thing for the fragment shader. At compile time, fragment output matches pipeline color attachment. So we know that fragment shader deals with color stuff. Types and semantics are valid, right? So we return fragment function and we return vertex function. Again, all of this is being baked inside of this call right here. Set the pipeline format, the vertex shader, and the fragment shader for the configuration. Okay, so that is that. And then we are back to our function right here. Pipeline descriptor is compiled into pipeline state. So render pipeline state equals compiler, new render pipeline state with descriptor, which had basically all the stuff that we did before. Compiler task options, which is just an archive file. If it doesn't exist, it doesn't exist. And then we have a placeholder for errors, right? Again, this script has a thing where the internal render pipeline variable is the same name. This is the same name as what we have for it's the same name as what we have for this guy right here, right? And I don't like that, because the internal name should be a little bit different. But basically we're running all of this stuff, and it's gonna return a compiled pipeline, right? So notice that after we run this, we return a compiled pipeline to this variable. Okay? So I know it's a little bit spaghetti, but I'll quickly run over it again and put everything together. So when this happens, this is point of no return. Okay, guys, point of no return. What happens internally? Shader code is finalized, right? Hardware specific state is created. Attachment formats are baked in, and execution paths are fixed. Okay, so we output this variable here, which is the GPU executable. Okay, from this moment on, the pipeline is immutable, fast to bind, safe to reuse forever. So actually, the pipeline is being called every frame. All right, but here now, the pipeline exists, so now we return the variable. The pipeline exists, but nothing yet. After compilation, no frame has run, no render targets exist, no vertex data is bound. Okay, the pipeline is dormant. A loaded program sitting in memory waiting to be run. Okay, so we do have a loaded program, like a .exe file that's sitting in memory and waiting to be run, right? And this is all for the GPU, right? So Santa Claus is coming for the GPU, is giving a gift to the GPU. Pipeline is activated during a frame. So then now we get to render, sorry. Pipeline is activated during a frame. Render frame to view. Now we have our encoder. Where is it? Configure the encoder with the render pipeline state. So render pass encoder, set render pipeline state, render pipeline state. So here now is where we actually use the compiled pipeline and configure the encoder with the render pipeline state. We actually use the compiled pipeline and we associate it with the render. This is the moment the pipeline becomes active. No execution happens yet. This just tells the encoder which pipeline to use. So all that work we did, we baked into this variable, and now the encoder knows which pipeline it must use. Pipeline and render pass must agree, okay? MTL4 render pass descriptor, configuration, view current metal for render pass descriptor. The render pass provides the drawable texture, its pixel format, load, store rules, okay? Metal checks internally that the pipeline.color format equals the render pass texture format, okay? If not, encoder creation fails or draw is rejected, okay? Create a render pass encoder from the command buffer with the views configuration, okay? I'll have to get into this when we go over render pass, But I felt it prudent to go over the pipeline first before we get to the render pass. Just because I think it's more rudimentary and stuff, right? But we will dive into this at some point. This is more render pass stuff, but the important thing to know, configure the encoder with the render pipeline state. So the render pass encoder now knows which pipeline to use. Okay. Draw call uses the pipeline. So here we have draw the triangle, right? And render pass encoder, draw primitives, MTL primitive type triangle, vertex start 0, vertex count 3. So of course our triangle has 3 vertices. So we have 3 vertices and we basically run it. We do the drawing. Now the pipeline finally executes. Vertex shader runs 3 times. Fragment shader runs per pixel, right? And remember, fragment shader is color, right? So every pixel in our in our thing is a slightly different color, right? Or maybe the same color if you go all the way here. But the fragment shader runs 3 times because we have 3 vertices, 1, 2, 3, and the vertex shader runs 3 times, 1, 2, 3, 3 vertices, and the fragment shader runs per pixel. Okay, so that is that. The next frame is same pipeline, new render pass, new data, right? And it's new data because of course the triangle is rotating and all of that stuff. So let us go into what let us just go into what the pipeline consumes. The pipeline consumes shader functions, attachment formats, and fixed execution rules. What does the pipeline, right? That's what the pipeline consumes: shader functions, attachment formats, and fixed execution rules. What does the pipeline ignore? The pipeline ignore vertex buffers, argument tables, the viewport, frame timing, draw count, all of that stuff. These things that it's ignoring are per frame concerns, right? But the pipeline, all the pipeline consumes is shader functions, attachment formats, and fixed execution rules. All right. We also want to, so I promise that we'll give a big picture overview again. So at app startup, we create a compiler, we create the pipeline descriptor, and we compile the pipeline state. And when we compile the pipeline state, right, after all this returns, this is where the pipeline is born. So now the pipeline is born because we have our guy here that has our pipeline. This is sort of the call. This is the call to the renderer to actually do the compilation. But then we actually, this is just the call. But then here is where the actual compilation happens, inside of the compile render pipeline. Okay, so this is a function that basically at the end of it, we actually compile the pipeline and then we return that compiled pipeline. Notice that we have inside of this function, we have configure render pipeline that does a lot of the heavy lifting and stuff. Configure render pipeline, right? So let's go to configure render pipeline, right? So we have our pixel format, we have our make vertex shader configuration, make fragment shader configuration, return pipeline, render pipeline descriptor, right? And then of course we know our make vertex shader configuration and make fragment shader configuration. But render pipeline descriptor is here, and that's what's returned to our descriptor variable, which then goes here, which then creates our compiled pipeline, right? So just a little spaghetti thing. So again, app startup, create compiler, right? So create compiler, create pipeline descriptor, compile pipeline state, return that pipeline here. So now we have a compiled render pipeline. Frames begin, create new render pass. Create new render pass per frame. Set. We're gonna set our create new render pass. Set our pipeline. Set pipeline. Then we're gonna draw, present to the screen, and all of that stuff, and repeat. Okay. A render pipeline is a pre-compiled immutable GPU execution configuration that defines how shaders run and how their output are written, reused across frames but paired with a new render pass each frame. All right, so this render pass stuff is moving, like it's actually happening each frame. All right, and just a high level thing. So we have our Metal 4 renderer file. We have init with Metal Kit View. Where is that? Init with Metal Kit View. Compile render pipeline. Compile render pipeline, and then inside the compile render pipeline, we have create default metal compiler, configure render pipeline, compiler task options, which we're not going to get into, and then new render pipeline state with descriptor, which creates our compiled pipeline. And that's pretty much it, guys. I know it's spaghetti, guys. I know it's spaghetti. I apologize. But you know, this, I think this is like one of the most important pieces right here. You know, but that's it, pretty guys. It's not. It's actually not too difficult. Once you really review it a couple times, you'll see that it's not too bad. You know, just know that, you know, we have a compiled pipeline, but it doesn't really do anything until we actually associate it with a render pass, and you know, we associate it with a render pass, and then we get to drawing. Okay. This is Cuda Education, guys. Like, subscribe, share. You know, be the leader in your community. If you have anyone that is artistically inclined, you know, please let them know about this stuff, so that they could use their creativity in the modern era. Also, you know, in the description below, you could basically get this Hello Triangle app. You could run it on your machine. You know, this actual Hello Triangle app, it actually, you could run it on Metal 4 if you have the Metal 4 renderer on your machine, or capabilities on your machine. You could also just run it with the regular Metal renderer. It will still run. Now, maybe the execution path will be different because I'm doing Metal 4, but you know, I think it's somewhat similar, and you could kind of follow along either way. So yeah, guys, this is the number one place for you to learn Metal, Apple Metal, and we're going through this stuff line by line and learning how to put a triangle on the screen, and actually a rotating triangle at that. So this is the pipeline stuff. Pipelines are important because we basically, it's sort of the agenda of all the things that we want to do, and we have to break that down to GPU executable code, so that the GPU could actually do its thing. You know, the GPU is about drawing stuff and you know, presenting to the screen. But just know that in the background, the operating system is really what controls all of this. The metal is just the renderer, right? So metal is just dealing with what's actually drawn, and then it reverts back to the operating system. Anyway, guys, thank you for watching. Have a great day.